what we're being asked to do here is find the volume using a triple integral between the sideways bowl and this plane, which also happens to be a cylinder. I'm going to draw the sideways bowl first. I tend to only do this well if I actually just turn it sideways, but I can't think of a situation where I wouldn't be able to turn it sideways. So there we go. Hey, there's our sideways bowl. Yay! Now, what does that plane look like? Well, we've graphed that plane before. It is a cylinder. Y plus 2z equals 5 looks something like this, right? But then it goes like that because x can be anything, and it just looks like that. Now what am I going to do? I can see that this plane coming down is going to chop this at an angle. So all I'm going to do is see what I get when I use that plane and chop this as an angle to get this. So this is going to be the plane hitting the region, and we can see that the region on the left is just the bowl. The region on the right is going to be the plane, and that's what we're going to use to start setting up the integral. And I'm going to get rid of the extra lines because I don't need them anymore. I do need to start setting up the integral. So triple integral, room, triple integral, room, triple integral. I do have to decide what order I'm going to do things, and then do some smooshing. Now the order for me is obvious because if I try to do z first, sometimes the flat side's the top, sometimes the bowl is the top. X looks just as bad. So what I'm going to do, seeing how I actually can solve each equation for y, is just chop first parallel to the y-axis. So all we have to do is draw a line parallel to the y-axis. I need to know what is y as it enters the region. Well, it enters at the bowl, so that's just y equals x squared plus z squared. It leaves at the plane, and I need to know what y is there. Y equal to 5 minus 2z, like that. And that's going to give me orders with respect to y, and it enters at x squared plus 2z squared, and leaves at 5 minus 2z. Now the next thing that's going to happen is we're supposed to smoosh. All right, here we go. Smoosh. Now what happens, right, as I look, the bird's eye view is standing way over here on the right, and as I look to the left, this is going to take this and smush it against the xz plane. Now what am I going to see? What I'm going to see is the shadow of this circle, is the projection, smooshed on there, and so what I would need to do is find the equation of this circle. Well, the equation of that circle is where the two surfaces hit each other, and so I'm going to set the y for one, which is x squared plus z squared, equal to the y for the other, which is equal to 5 minus 2z. And I need to know what that is. Fortunately, that's just algebra. I'm going to bring the 2z over here. So this is x squared plus z squared plus 2z equals 5. I complete the square like they made us do in algebra, and I'm going to get x squared plus z plus 2 squared, and I'm adding 4 to both sides, so this is 9. What we see is that this is a circle, oh boy, in the yz plane, no, xz plane, whose center is at 0 minus 2, and whose radius is 3. So this is what we're seeing from the side. And now what we need to do is to start drawing lines parallel to one of the axes. Let's see here. I think what I'm going to do is draw lines parallel to the x-axis. I think that's going to give me an easier thing to solve for. So I'm going to just draw a line like that. Those things have the same z coordinate, so I need to know what the x is, right? So this is going to be, let's see here, the square root minus the square root of 9 minus z plus 2, quantity squared, there we go, comma z. This is going to be positive square root of 9 minus z plus 2, quantity squared, comma z, and we know that that's actually going to give us the limits of integration for x, so I'm going to put in dx next, and then I write in these very long things for the limits of integration, so this is minus the square root of 9 minus z plus 2, quantity squared, then positive 9 minus z plus 2, quantity squared, like that. I would like to do one more smush. I don't know if I actually can, but let's draw a little teeny smush and see what happens. Smush. when you smush, what are we doing here? We're smushing against the z-axis, and all we're going to see is the shadow of this circle as it hits. Well, we know that the center was at -2. It went up 3, which goes up to 1, and from the center going down 3, it goes down to -5. And so that's going to give us, I think, the limits of integration for the outermost integral. And while I think that was a little more complicated than I would like, that is an honest integral. This is the kind, actually, I think, where when you're actually going to be doing science, this is the kind you're going to see. So there's an example.